Hello, lovelies, and welcome to the first episode of Oh My Lloyd, Math with Style with Miss Lloyd. So today for our first episode, I'm going to talk about some of my favorite things in math, and those are called asymptotes, mostly because of how they sound, probably. I mean, I teach teenagers all day, so you really can't blame me. So first up on the list is vertical asymptotes. So vertical asymptotes are values of x that would make our denominator equal to 0. So what I'm talking about is a function kind of like the one you'll see on the right. So we have a polynomial dividing with another polynomial, so a polynomial fraction, if you will. And so we're looking at things that if I plug them into the denominator would set that denominator equal to 0. So as you should know, if you're watching videos about asymptotes, we cannot divide by 0. It's just not something we can do. I like to tell my students that this would be a case where the world explodes and there's no more tacos because, I mean, as far as we know, Earth is the only planet with tacos. So it's a very, very sad thing to do and not something we do in class. So just like with your own asymptote or maybe someone else's asymptote, it's not something you should really touch, especially in math class. So this is a part of the graph, or part of our coordinate plane that our graph cannot touch. So you can get as close as you can, but you're not actually going to touch it. I actually have some interesting conversations with students during dances about this kind of situation. So looking at the problem that we have ourselves, we're looking at our vertical asymptotes. So we're looking at the denominator. So because I have this polynomial and I'm setting it equal to 0 or figuring out when it is equal to 0 so that I know what to avoid, I'm going to need to factor it. Luckily, I know that this is a difference of squares, and so our factors are going to be x plus 3 and x minus 3, and I'm setting those both equal to 0. So when we solve, we know that we're going to have an asymptote at negative 3, and where x is positive 3. So these are our vertical asymptotes. They're going to be going up and down. Of course, when I draw them on the graph, I know that they're not really technically there. They're kind of like an invisible force field, if you will. And so I create them as a dotted line. And I know that this is the area that my graph is going to get pretty close to, but not actually going to touch. So these are our vertical asymptotes. And I'm going to abbreviate because I'm a mathematician. I can't spell, and I'm actually pretty lazy, to be honest. Next thing I'd like to talk about are our horizontal asymptotes. So horizontal asymptotes are going to be going side to side. These are y equal to lines. And these tend to be lines that we don't touch, but the asymptotes, the horizontal ones, are more like guidelines than actual rules. Sometimes you do end up crossing them, and so it's not completely illegal to not cross them. So one of my favorite movies is Pirates of the Caribbean, and the second I learned about the horizontal asymptotes, and sometimes we actually do cross them, sometimes we don't, this was the scene that came to my mind. So the code, in this case our code for horizontal asymptotes, are a bit more like guidelines than actual rules. So in order to figure out what these guidelines are, we have 3 situations. All of these situations are going to be determined by the degree of our numerator and the degree of our denominator. So we're going to be comparing them. So for our first comparison, we're looking at when the degree of the numerator is higher than the degree of the denominator. So what I'm talking about here is if we have something like x cubed over x squared. So in that case where we have a higher degree, the 3, than the 2 on the bottom, we wouldn't have a horizontal asymptote in this case. So you don't have to worry about crossing something that may or may not be able to be crossed. Horizontal asymptotes aren't exactly my favorite because sometimes you touch them. So it's kind of like, I don't know, if you really have to scratch your butt at home. So that kind of situation. Next one is if our degree of our numerator is equal to the degree of our denominator. Then we'll be looking at the leading coefficients. So by that, I'm talking about if we have a 3x squared over 7x squared. Then we'll be looking at the leading coefficients, the 3 and the 7. So y would be equal to 3 over 7. So that would be our horizontal line that we may or may not be able to touch. And our very last instance is if our degree of our numerator is smaller than the degree of our denominator. So in this case, we would have something like x squared over x cubed. So in this case, it doesn't matter what's in front. You could have a 7 on top and a 3 on bottom, and one be negative, one be positive. It really doesn't matter. Our horizontal asymptote is always going to be y is equal to 0. And so preaching at you on and on and on about these different kinds of asymptotes could be fun, but it's a little bit easier to understand when you have an example that you can look at. So finishing off our example that I had above. So we already figured out our our vertical asymptotes here. So again, I'm a little bit lazy. So vertical asymptote, I know is where x is equal to 3 and negative 3. So I like to try to graph those right off the bat so that I know what I'm not supposed to touch. So again, these are our vertical asymptotes, so there'll be some kind of dots going in a vertical line. So I know kind of what to stay away from. I don't want to see my students touching any kind of asymptotes in class, and so I'm going to try to not touch any asymptotes in front of you guys. I hope you would appreciate it. Alright, so here we're also going to need to look at the horizontal asymptotes. So in order to do that, I look at my degrees. So I have a degree of 2 on the bottom, and technically this is a linear polynomial on top, so I have an x to the first. And so I know that since I have a larger degree in my denominator, that my horizontal asymptote is going to be equal to 0. So again, I want to graph that, and so where y is equal to 0, that's going to be our x-axis. Sometimes it freaks people out whenever we have an asymptote on an axis. It's kind of a mind bender, so it's totally fine to have. Sometimes it is along the axis, sometimes it's not. It just depends on the problem that you have. And so for the rest of this, you can either plug things into your calculator to see how it looks, or if that's not something you have readily available, then you can hashtag t-chart is what I like to call it. So just making a t-chart of your graph. So plugging in what you don't know, or some easy numbers to figure out where your graph is actually going to be. So then one of the first things I like to do is put my asymptotes around, because I know what I'm not allowed to touch, but I don't know what's going to be happening around the things I'm not supposed to touch. So I like to plug in, okay, I know I have a negative 3 that I can't touch, and I know I have a positive 3. So I want to pick numbers that are around those numbers to plug in, and then I know I can't actually plug them in because they're asymptotes. It's going to be dividing by 0. It's going to be undefined if you actually plug it into your calculators, or you'd be dividing by 0 if you're plugging it in by hand. And so I want some numbers that are around these. So I'm going to pick negative 4 and negative 5. And so we're just plugging these into the x's from the original equation. So an example for the negative 5, we're plugging in negative 5 plus 2 over negative 5 squared minus 9. And so whenever we solve that out, we end up with about negative 0.19. Same thing, we plug in negative 4 the exact same way. When we do that, we end up with about negative 0.29. Again, we can't plug in 3, but I still want some things that are around 3, so I'm going to try negative 2, 0, and positive 2. So just some numbers that are around our asymptotes so that we know what we're getting close to. We know what kind of shape we're going to be looking at, because we could end up with a parabola type shape. We could end up with a cubic function in the middle there. It really depends on what's going on. So when we plug in our negative 2, we end up with 0, which is totally fine. So this is going to be an instance where we end up crossing or going through our horizontal asymptote. So again, they're kind of like guidelines than actual rules. When we plug in 0, we get negative 0.2 repeating. And when we plug in positive 2, we get negative 0.08. And again, we can't plug in positive 3, but I still want to see what's around it. So I'm going to plug in a couple positive numbers. So 4 and 5 will do. So when I plug in a positive 4, I end up with a 0.86. And plugging in a positive 5, we get about 0.44. So then looking at these, I want to start plugging them in. So I'm going to graph these points that I've just found. So for my -5, so at this -3, 4, 5, and going down a little bit from my x-axis, and then same thing, just a little bit farther. I know this isn't going to be exact. It looks a little bit more like -0.5, but it's just kind of the gist of it. So I know that as I'm going closer to my asymptote, then I'm going to be going down. So it gets lower as we got closer. And if I'm going the opposite direction, it's going to be getting closer and closer to my x-axis. So that y equal to 0 asymptote, my horizontal asymptote. Next, I want to graph all of my lovely points that I found in the middle. So then here, I've got -2, 0. So again, this is one where it does cross. More often than not, it's when you have an area in the middle that you would be crossing. Again, they're more like guidelines than actual rules. It's not my favorite part about horizontal asymptotes. Again, I'm more of a fan of the vertical ones. And then at 0, we're at -0.2 repeating. And then at +2, we're about at -0.8, so pretty close to -1. And so what this is doing is I like to start in the middle. As I'm going to the right, that means I'm getting lower. And as I'm going from the middle to the left, we're getting higher. So again, they get really, really close to those asymptotes, but we don't touch them. And then our very last bit that we're going to graph is our right side of our last asymptote. So I'm at +4, and then almost at +1, so 0.86, and then at +5, we're about 0.44, and so I know we're kind of coming from above and going down lower. And you can plug in more if you'd like. If you would like to check these on your calculator, I have a coworker who has some amazing videos on how to plug things into your graphing calculator if you use a TI-84. And so if you want to check that out, I have put a link to his video in the description of this. So feel free to check that out and like and subscribe to his page. Even though we're in a competition, he's still like my brother, my math brother. So any likes and subscriptions or sharing is greatly appreciated for either of us. And then my last thing that I'm going to show you, this is a little bit of a different thing. So we'll look at vertical asymptotes, horizontal asymptotes, but we're also going to take a peek at what is called a discontinuity, but I personally like to call it an asymptote hole because why not? So here for our next and last example, we have two polynomials, and so in order to do my vertical asymptotes, I'm setting my denominator equal to 0. So by factoring that, I know I have my x plus 5 and x minus 2. I'm also going to want to factor the top just so that I can see exactly what's going on, and personally I think it's a little bit easier to plug some things in whenever you're doing the hashtag t-chart. And so when I do that, I know, okay, this is another difference of squares, so I have x plus 2 and x minus 2. So before you typically look at graphing these situations, you look at simplifying them. And so in this situation, I have both an x minus 2 and x minus 2 on top and bottom. So when that happens, we typically reduce by that factor, leaving our equation, or what we're going to be graphing, as just x plus 2 over x 2, even though we got rid of it, it still affects our original graph. So when I'm talking about my asymptotes, so vertical asymptotes to begin with, so our vertical asymptotes is when our denominator is equal to 0. So I would have x is equal to negative 5. Yes, the x minus 2 went away, but it's still going to affect it, not anymore as a vertical asymptote, but in this case, it's going to become an asymptote hole, or discontinuity. At x is equal to 2. So if I plugged in a 2 to the original equation, I would still end up with a 0 in our denominator. So we still have to pay attention to it. So basically my graph is going to go on as normal, and where x is 2, I'm going to have just a little blip or a hole in my graph. So again, an asymptote hole. And then I also need to worry about if I have any horizontal asymptotes. And so here I started off with our degrees in our numerator and in our denominator being the same. So this means that we're doing our leading coefficients over each other. They don't have any numbers in front, so they're both leading coefficients of 1. So this will be a horizontal asymptote of y equal to 1. So I have my horizontal asymptote here. I have my vertical asymptote 1, 2, 3, 4, 5, negative 5. And then I know whenever I'm doing my graphing that I'm going to have a hole in my graph where x is equal to 2. So from here, we're going to want to make our hashtag t-chart. So I know I have a situation at negative 5. So I'm going to figure out negative 6 and negative 7 around it. And then I know I'm going to have a weird thing at 2. So I'm going to want to figure out some stuff around there. So I'll try negative 4, pretty close to the 5, and I'll try positive 1, that's pretty close to the 2. And then for the other side, we'll do a 3 and a 4 just to check things out. So when we plug these in, maybe I won't do 4 because I am kind of lazy and this video is getting a little long. So when I plug in my negative 7, I end up with 2.5. When I plug in negative 6, we get a nice pretty number of 4. Plugging in negative 4, we would end up with a negative 2. Plugging in a positive 1, we would get a positive half, so 0.5. And then plugging in a 3, we would end up with not the prettiest number, but about 0.63 when we round. So then now I'm going to graph my pretty little points that I have found. So I've got my negative 7 and then 2.5. So about there. And then 6, 1, 2, 3, 4. So I know as I'm going to the right, we're going up. As I'm going to the left, we're going down. And we're going to get closer to those asymptotes as we keep going. But again, we're not going to touch them. Very inappropriate to touch those in math class. And then I've got my second set here. So my negative 4, I'm at negative 2. So it looks like I'll be coming from below. And positive 1, I'm at positive half. And then 3, so I'm going to skip 2 because I know there's a hole there. And then I'm at 0.63. So I know I'm coming from below, going round and through, and then just kind of getting really close to those asymptotes, but again, not touching them. And I know you're like, oh, but you just said that there was going to be a hole at 2. So I like to draw it first. I typically use pencil. With my handy dandy app, I can just erase it too. And I know I'm going to have a hole right here where the 2 is that we just kind of skip over. And there we go. Those are our asymptote holes, or again, our discontinuities. I still think asymptote whole is a lot funnier. So if you like this video, or if you know someone who maybe needs a little bit more help when it comes to asymptotes, please like, subscribe, and share.